Make we look upon them things there now. So we are continue study the C-set mathematics syllabus, right? At least the topics dominate. Alright. So we have them things there. Closure, associativity, commutativity, commutativity, distributivity, additive identity, additive inverse, multiplicative identities. Alright. I should have put this right up there, so you know, let me make it go up there. The additive inverse business here. Alright. So, here now. Closure. What that? Want to know what that be? Now, it's like a case where you have only a certain type of number allowed, or only a certain type of number will be the answer to some problems, but not other number. It's like you close the door, you shut the door, and say no other number can come in. Suppose me say, for example, the sum of even numbers now the thing is, if you have something like 2 plus 2, you give an even number. 2 plus 4 give you another even number, and so on and so forth. So basically when you add two even numbers, you get an even number. So you have closure there, so because no odd number not allowed, right? You don't allow any odd number to come in. So you have the building only even, and once all of the even number them come, you shut the door. Say nobody else allowed. So that's a closure. Alright? You close the door to them. So you see. Now, any question, remember say any question you can ask in the comment. Right? Now, this other thing there, let me tick off closure because we do closure since a while ago. Associativity. You have the associative law or the associative rule, whatever it is you want to call it. With a law or rule. Now, let me rub about this. Associativity. Why it really I say something like this? If you have some numbers, a plus b plus c, y equal a plus b plus c. Even if you put the b and c in a bracket here, so, or the a and b in a bracket here, so, you still get the same answer. You know, matter which two, which three, whatever number you put in a bracket. And then do that first. Now, the bracket is like an office, you know. And you have only business associates in that office. Right? Only those associated in terms of the business. They may not want meeting in the office. So the bracket like one office as well. B and C associates in the meeting. A the outside. But now A and B associated and C the outside. So you get the same answer on both of these. Now if you have A multiplied by B multiplied by C and you have B and C in a bracket, are the same thing as A times B times C when A and B in a bracket. So whether you associate B and C or A and B, same thing again. It's like say you have 5 plus 3 plus 2, and then you have the 3 plus 2 in a bracket. Then you have 5 plus 3 plus 2. I have the 5 and the 3 in a bracket. 3 and 2 are 5. 5 and 5 are 10. Over here, so now, 5 and 3 are 8. 8 plus 2 are the same 10. No matter what you do, in that case, once you have 3 numbers add to one another, they obey the associative rule or the associative law. You hear that? Then after that, you have this commutativity. Make we see how you go. Alright, so remember about this. Now, we do associativity already. Let me take off that. When it comes to this one here now, if we commute, it's a commutativity. If we commute means if we travel. Right? Like, we talk about early morning commuters. If you watch some of the news station, them, the news channel, and the news on the internet, they talk about early morning commuters, and they talk about the commuter train over America, right? And the other day, I see one Toyota Hiace bus named the Toyota Hiace Commuter. So, if you commute means if you travel. Now, suppose you have now A plus B plus C equal B plus A plus C. And the same thing if you say A plus C, C plus A plus B. So we see how this goes. Where you have A on the left, B in the middle, C to the right. And now we make B travel to the left and A travel to the middle. You get the same answer here, so. And then C plus A plus B. So, right here, so now we make C travel to the left, A remain, but B travel to the right. Now, it's like you say, 2 plus 5 plus 6. It should have been the same thing as 5 plus 2 plus 6. And it should have been the same thing as 6 plus 2 plus 5. And so on. Right? Now, 2 and 5 are 7s. 7 and 6 how much? 13. We try this one. 5 and 2 are 7. 7 and 6, 13. Alright, we will try this. 6 and 2, 8. 8 and 5, 13. So, no matter what you do, when it comes to addition, you have the same answer. If you are trying the commutativity, that means you make one number travel from this position to that position and so on and so forth. Suppose we try multiplication. Suppose you say 2 by 5 by 6. 1 way for the same thing as 5 by 2 by 6. Or 1 way for the same thing as 6 by 2 by 5. If we see 1. 2, 5, 10. 10, 6, 60. Alright, 5, 2 is 10. 10, 6, 60. Alright, it works so far. 6, 2 is 12, 12, 5, 60. So the whole of them are 60. Alright. So you say addition is commutative and multiplication is commutative. Now, suppose now you say you're going to have 10 minus 3. Is that equal to 3 minus 10? We just make two numbers now. 10 minus 3 how much? 7. 3 minus 10 how much? Different number, negative 7. So this equals 7 that can work. So subtraction in a commutative, right? What about division? Suppose you say 30 divided by 3. Wonder if it's the same thing as 3 divided by 30. No. When you have 30 over 3, the answer you get a 10. When you have 3 over 30, the answer get a 110. So this equal sign wouldn't work. So basically, subtraction is not commutative. You see that? Alright. Commutative means to travel. So the number of them can travel back and forth. You can rewrite number them in a different position, a new position where they travel back. So commutativity. We can try a thing here now. Different thing. Distributivity. Now this distributivity business here. Have something like this. If you have x multiplied by, and then you have a plus b, what you could have is x times a, that's a ax, plus x times b, that's a bx. You see? So, you distribute the answer them. It's like say, you have one shop, one corner shop, and you go town now, now the main hardware, where them who control the supermarket them and pack up this whole ton load of things. So you're buying a bulk now. When you leave the hardware now and go to your shop, a times x equal ax. You sell somebody and then go on this way and then you add x times b a bx. So you sell somebody or something that bx and then go on and then you add. So you basically distribute goods, you know. So you become a distributor, right? So these are the distributive rule or law. You see that? Distributive. So it's like, let me listen now. 3 multiplied by a plus b. You have 3a plus 3b. That's what happened. If you have 3 times a minus b, you have 3a minus 3b. Right? But you would write it with like multiplication and division. 3 times 8 multiplied by b. And the same thing as 3ab. So, with the multiplication and the division, you know, deal with thing there. You know, really deal with distributive identity, the distributive law. Are really addition and multiplication and subtraction, you deal with it. So distributivity. You open the bracket and distribute it. You open the shop and you sell to this one and then gone, so you sell to this one next one and then gone. So you distribute the goods all over the place. Alright. Let me see something else you know. What you call it? Additive identity. Now, we could find out what that is. Is a certain number, you see? The additive identity is a certain number. If you add any number to that special number there, you're going to get a certain answer. And that answer are the same thing as the number where you just added to. So, I wonder what that could that be. Alright. The thing is, if you say any number, say x plus 0, the answer is x. Like 7 plus 0 is 7. So, what you have is that 0 are the additive identity. When you add a number to it, the answer you get are the same as the number. It's identical to the number. Alright? So, 0 are the additive identity. Now, the next thing are the additive inverse. You see, when you have two numbers there, right, and you add them, the answer you get are the additive identity 0. So, a number like 5, what would be the additive inverse? What is it that you're going to add to 5 to get 0? It has to be negative 5. So, 5 plus negative 5 are the same as 5 minus 5 equals 0. So, the additive identity of 5 is negative 5. In fact, when you have a number, the additive identity are the same number with a different sign. If I did negative 5 and you want to find the additive identity of negative 5 or positive 5 are the additive identity, because the two of them add. See, though, the additive inverse me attack, my gosh, me attack by identity for. So, if you have 5, the additive inverse of 5 are negative 5. Because they add to give you the additive identity 0. You see? So now, the thing is this. The additive inverse of any number x is negative x. The additive inverse is what them add and give you 0. Alright? So that's the additive inverse. Just discuss them things that you know. Alright. Oh, the multiplicative identity now. And the multiplicative identity. And then after this, the multiplicative inverse. Now, let me multiply. Let me erase all them things. The thing is now, the multiplicative identity. The multiplicative identity, I want a certain number, you know. Now, if you multiply something, or if you, that's now. Yeah, multiply a number by the multiplicative identity. The answer you get will be the number. I wonder why it could have been. We will say 4 times the multiplicative identity, you get back 4, the identical number. What the multiplicative identity going to be? It has to be 1. 4 times 1 is 4. You see? So, the multiplicative identity, I want a certain number. When you multiply a number by it, what you get are really the same number, the identical number, right? So that's the multiplicative identity. The multiplicative identity are 1. If you multiply a number by it, you get back the identical number, the same number. Alright. The next thing they have now we saw, if you know about, are the multiplicative inverse. Now, earlier we used to say the additive inverse. When you add a number to its own additive inverse, you get the additive identity 0. Now, if you follow the line of argument, when it comes to the multiplicative inverse, if you multiply a number by that number's own multiplicative inverse, you want to get the multiplicative identity. And you know what the multiplicative identity be? Alright. A while ago we saw 1. But in that case, since we use 4 already. So we use it again and say 4. What is the multiplicative inverse of 4? Well, when you multiply 4 times the multiplicative inverse, the answer you get are the additive inverse, 1. Which number you multiply 4 by? If you get 1. Well, you're going to multiply by 1 over 4. So 4 times 1 over 4 are 1, you know. So that's how the we normally call it inverse. But are really the multiplicative inverse you are talking about. You see? So that's how the multiplicative inverse. So the multiplicative inverse of x is 1 over x. Right? So it's 1 over x. So let me take multiplicative inverse. Alright, so any need for clarification, any question or so on, just let me know. Right? In the comments.